Good afternoon. So today we'll be presenting the Contemporary Motion Sensor by Matthew Manig and Yves Batikan. So in this presentation we'll have the introduction, objectives, project materials and cost, development and design, lessons learned and future plan. To put it into context, as the amount of scarcity increases in a society and economy, there continues to be a direct proportion of crime rates and threat of security. It is becoming increasingly important that business owners, homeowners, and even museums have a secure and proper method of securing their belongings. In order to secure these possessions effectively, modern technology must be used hand in hand. In this project, the infrared motion sensor is utilized to protect and alert the owner of an intruder incident. PIR, or passive infrared sensors, are devices that have the capability to detect motion through filtering the infrared radiation around. They can detect the change in heat energy using pyroelectric sensors in the environment around. Our overall objectives in this project is to discover the capabilities of a motion sensor and Raspberry Pi in order to create an effective system that secures one's own possessions. We also hope to understand the capabilities of Python script and coding in creating these systems. And lastly, through this project, we plan to learn and improve our ability to debug and create scripts that can tailor to our specific needs. For our project materials and cost, we have several project materials including the Raspberry Pi, monitor, Bluetooth speaker, iPhone, jump wire, and infrared motion sensor. Some of these items we already previously owned, including the iPhone, Bluetooth speaker, monitor, but some items we had to purchase on our own, including the jump wire, infrared motion sensor, and the Raspberry Pi 400. The Raspberry Pi 400 actually includes the mouse and keyboard within it. Concerning the development and design, the design of this project involves the collection of various materials, time taken towards personal research along with various trials and errors. Some of the materials had to be purchased as previously mentioned, and the following is a record of the steps leading to the final product. First, we want to make sure we have the correct jumper wires connected to the right slots. We have to take 3 jumper wires and connect each one to pin number 2, which is 5 volts, pin number 6, which is ground, and pin number 12, which is GPIO. Then we connect pin number 2 jumper wire to VCC on the motion sensor, which is the blue diagram right. Then we connect pin number 6 jumper wire to ground on the motion sensor and pin number 12 jumper wire to out. Afterwards, we can turn on the Raspberry Pi and connect to the monitor. We then open a Python editor, like the one listed, which is Thony, and create a new file named motionsensor.py. For the main code, we want to import the time and GPIO libraries using the GPIO board system, setting the motion pin as 12. In the code, we want to create a while loop, and under that while loop, we want to set the motion to equal to the input from the motion pin 12. Then we can create an if statement, so when the motion is detected, it is equal to 1. So when motion equals to 1, we can print motion detected, otherwise we can print motion stopped. Finally, we can just use a keyboard interrupt command to stop the system. After creating the base code for the Raspberry Pi and the motion sensor, we can now start to add the Bluetooth capability. So first, you want to make sure you want to update your Raspberry Pi to the most recent version of Bluetooth plugin. You click the Bluetooth icon on the upper right corner, which is in the diagram to the right of this, which is the blue symbol. Now click on Add Device and you can search for your devices and click Pair. Once connected, your Bluetooth speaker would have a green tick. You can download an alarm sound online, but you would have to convert the MP3 file to WAV file compatible file. When you do that, you can open your motion sensor PY file using your Python editor. You should import the Pygame library and you can load the WAV file to the Pygame function. Afterwards, you can create a while loop so that if the motion is detected, the Pygame function plays the alarm WAV file. After adding the Bluetooth capabilities, now we can start to add email alerts. First, I open the terminal and I type sudo apt-get update along with sudo apt-get upgrade to update the Raspberry Pi. Afterwards, I install the postfix package by typing sudo apt-get install libsasl2 modules postfix. Afterwards, we select the internet site when asked for configuration. Then we enter the hostname of the Raspberry Pi. Next, we can log into your Gmail account. You enter your username and your password, and when you log in, you click the security section and apply for a two-step verification using a mobile phone. It will give you a one-time password, and then you will create an application password. The application password is an example shown to the right, which is ANXN, BMIO, LMNP, and FCCI. When it says generate, you copy this generated password and paste it to your notepad for later use. Now we can open the terminal again, and we want to create the file sasl_password under the directories postfix and sasl. In this file, we want to write down smtp.gmail.com 587 with your username at gmail.com and the application password that we save for later use. We then can create a hashdb file by entering this to terminal. Afterwards, we can also change the permissions of the sasl_password file, which is shown in the code that I had written below. Afterwards, we can configure the postfix relay host entry where the file relayhost equals smtp.gmail.com .587. We can then add the entry on the left to the file postfix/main.cf. It includes enable SASL authentication, disallowing methods that allow anonymous authentication, location of SASL password, enabling TSL encryption, and location of CA certificates. Then we can save the file and return to the main terminal. We then restart the postfix service, and then we can create an email text using VI Editor to type a warning. Here I wrote warning in all caps, motion detected, and alert. Then we can enter the terminal a code that says send email -t, your username at gmail.com, and then email.txt, which would be the text that we just created. We then want to open the motion-sensor.py file and import the OS library. We want to add the OS system function so we can execute the previous command to the terminal. Then we can run the Python file and an email will be sent when motion is detected. Now we can proceed to add SMS alerts. To do this, we have to sign up for a free Twilio account and verify your account with your mobile number. Once you verify with your mobile number, you can check for 3 important pieces of data, which include account SID, auth token, and your new Twilio number. Now you can open Terminal and use VI Editor to create a new file titled sendtext.py. Then you can type in the following entry and enter your account SID and authentication token. After 2, you can enter your mobile number, and then from, you can enter the Twilio generated number. In the body section, you can enter the warning, alert, and motion detected. So now we want to go back to terminal. We can run the code python3 sendtext.py, and now you can check your mobile number for the text. Afterwards, we can open the motion-sensor.py file and add this below, so that the OS system function can be able to run the python3 sendtext.py. You also want to make sure that both sendtext.py and motion-sensor.py are in the same desktop folder. Finally, you want to run the motion-sensor.py, and all should be completed from now with a Bluetooth sound alert, email, and SMS alert. Now we can see the end results of our code. We've imported the GPIO library, the time library, and the OS library. We've set the motion pin equal to 12 using the GPIO board system, and we also imported Pygame in order to allow for audio to be played. We also created a while loop shown here where we set motion equals to GPIO motion pin. So when motion pin equals to 1, that means that motion is detected. When motion equals to 1, Pygame will play the alarm audio. Afterwards, it'll print motion detected. Then it will tell terminal to execute the send text file. Then it will tell terminal to send the mail. So when motion doesn't equal to 1, then it'll print motion stopped. So when we click run, it'll continue to say motion stopped until step 2, where we wave our hand in front of the sensor, where it will say motion detected. Then, via Bluetooth, the sound will alert through the speakers. Afterwards, we're going to get an email alert saying warning motion detected alert from our postfix that we set up earlier. Then we will get a text message alert set up using the Twilio trial account, which will say alert motion detected. Here we have a video demonstration of it happening in real time. There were many lessons that were learned. One of the lessons I learned was having to pay attention to the detail of your code. Sometimes we might not realize that I created a typo or missed a hyphen, but that single character can stop our entire system. In the project, I had initially typed password with one S, and the text alert never even sent. It took me a long time to debug and sift through every process to even notice this mistake. Another lesson that I learned is the ability to be creative and add on to your system. At first, we intended to just add Bluetooth sound. Once we were able to achieve that stage, I felt like there was more we could play around with, so we brainstormed and came up with adding email and text alerts. Though the coding and process was laborious, the end result shows a much more complete and refined motion sensor system. In the future, we hope to create more add-ons to the system. If we had more time and a higher budget allowance, we would add a camera that can record the incident of the intrusion, along with sending it via cloud so that the owner can watch a replay of it. In addition, future plans could also create an application that hosts a cloud recording, along with combining the motion sensor with a security camera as well. So in the event of a motion sensor, it would do the basic functions in this project: sound, email, SMS alert, with the add-on of security camera cloud recording, along with developing an accompanying security app. We also relied on various sources in order to use Postfix, Twilio, and also to set up a motion sensor with our Raspberry Pi. Thank you, and we hope you learned a lot about the process behind creating a motion sensor that can send an email, Bluetooth through sound, and SMS alert.